Okay, so I know basically the velocity of the two cars that I've got here. Okay. I also know the acceleration of these two cars. And again, these would be like the absolute. And what I'm looking for is I want to find the velocity and the acceleration of B with respect to A. So I want to find the velocity of B with respect to A. Okay. And writing my equation out, which again is sometimes the hardest part of these. Okay. The velocity of B equals the velocity of A plus the velocity of B relative to A. And you can kind of think about it, we write it this way, kind of like a fraction where that A will cancel that A and you'll just be left with, the velocity of B. That's how, we'll kind of write this out, right? So the velocity of B with respect to A is that. So um, let's go ahead and write what we know here. So the velocity of B is this car right here, right? So it's traveling in that direction. Okay, that means that's going to be a 30-degree angle because it's going to be perpendicular. It's going around a corner, so it's going to be perpendicular to that angle right there. So instead of the angle being relative to the horizontal, this will be relative to the vertical, right? So the velocity of B is going to be going in the negative x direction, so it'll be negative 20 sine of 30 in the I direction and plus 20 cosine of 30 in the j direction. Okay, so that's the velocity of B. The velocity of A is very simple. It's going in a straight line in the negative x direction. I guess I should say, again, we're going to assume our standard, xy axes like this. So that's going to be traveling in the negative x direction at 30. So that's going to be equal to negative 30I, okay, plus the velocity of B relative to A. So solving that very simple vector equation, I can find the velocity of B relative to A, okay, equals 20I plus 17.3 J, and that's going to be miles per hour. So again, what I'm finding here is if I was in car A looking at car B, that's what it would seem to me that car is traveling based on the axis of me sitting in the car. So me looking in the car in A, looking at B, that's what it looks like it's traveling at. Okay. We will do the exact same thing for the acceleration. So the acceleration of B equals the acceleration of A plus the acceleration of B with respect to A, which is what I'm trying to find. So let's start with the easy one here. A is just traveling in a straight line. It is actually increasing its acceleration, but it's increasing it in the negative x direction, right? It's traveling to the left. It's going faster and faster and faster. So that acceleration will actually be negative 400 in the I direction. And again, that's because it's increasing its speed, but in the negative x direction. Okay. Now we'll go on to the acceleration of B, which is going to have two components. Okay, it's going to have a normal and a tangential component to it, right? Because it's going to have that normal direction like I have, this is the tangential direction. Okay, but it's also going to have a normal acceleration going in that direction, right? So let's start with the tangential acceleration. This is basically, he's hitting his brakes, so he's going to actually be slowing down, okay? And it's going to be in the same direction as my velocity was. Okay, actually it'll be flipped. My acceleration in the t direction will actually be in this direction because it's slowing down, which will be in the positive x direction, and that'll be 800 sine of 30, just like it was sine of 30 above, in the I direction, and then negative in the y direction, that'll be 800 cosine of 30. And this is basically slamming the brake. Okay, this is your tangential acceleration. Okay, your normal acceleration, okay, is going to be positive x, positive y, pointing towards the center of that circle, and it's going to be equal to v squared over rho, where again v is 20 squared, and rho is given to me as 0.3. And again, this will be cosine 30 in the I, and sine 30 in the j. But both positive because it's towards the center of the circle there. Okay. And again, this is my normal acceleration. Okay. So now I've got AA, got AB. I won't go through, I'll let you do the math on your own. Okay. But my acceleration of B with respect to A is just going to be AB minus AA. So I'll take that big one there and then just basically subtract off the negative 400i or add the 400i. And what I'll get is 1955 in the I direction minus 26.2 in the j direction. And this will be miles per hour squared. And I'll just leave it in vector form. Okay, you could always find square root of the sum of the squared if you wanted to, but we don't need to worry about it. And again, this is the acceleration of B relative to A. So sitting in car A, what does it look like B is actually accelerating? And because it's slamming on its brake going around that corner, it looks like it's accelerating very quickly in the x direction, especially because A is also accelerating in the negative x. So this expands that acceleration, makes it look like it's accelerating away in the positive x direction as quickly as possible.